Good day, everyone, and welcome to today's webinar, Practical Application of R-22 Interim Replacement Refrigerants and the Introduction to New Generation HCs, hydrocarbons, and HFOs, hydrofluoroolefins. My name is Jamie Hale, Chemours Senior Technical Training Manager. Later this week or the first of next week, you will receive by email a PDF of today's session, a Freon Opteon refrigerant guide replacement, product information on low quality refrigerants, and a link to Chemours literature selection. This is a NATE credited course, so if anyone needs NATE credits, please email me your name and your NATE ID number, and I will make sure that that gets submitted to NATE. The course outline today: who is Chemours? Regulatory updates, industry news, quality issues on refrigerants, basic system conversion guidelines, the introduction to hydrocarbon refrigerants, the introduction to HFO refrigerants, Chemours technical support and continuing education resources. And at the end, we'll answer any question that comes in. Make sure that you type your question in the chat section to the right of your screen. Back in 2015, DuPont spun off its performance chemical business, and the Chemours company was created. Today, there's over 7,000 employees worldwide, and we are still the leader in refrigerant manufacturing. In 2016, Chemours broke ground on the world's largest HFO manufacturing plant in Corpus Christi, Texas, and this gives us about 3 times the capacity of HFO refrigerants than we had prior to the opening of the new manufacturing plant. So we have plenty of refrigerant for many, many years, HFO refrigerants. In 2017, Chemours broke ground in the University of Delaware for its new Discovery Hub. This is a research and development center where all of the engineers, scientists, and R&D will be held. In 2018, Chemours acquired ICOR International, an Indianapolis refrigerant-based company. And this was Chemours' first acquisition for a refrigerant manufacturer. This is the Discovery Hub at the University of Delaware. As you can see, it's 300,000 square foot plus building. It will house all of the engineering, all of the R&D, and it is a 4-story building and will open up next year in 2020. So now let's talk about regulatory updates. First, we'll talk about the R-22 phase out, of course, the Kigali Amendment, and the CARB proposed regulations. As I'm sure most of you know, this is the last year for production and importing of virgin R-22. There's still plenty of R-22 available today, but will R-22 be available in the near future? That's a good question. Nobody knows the answer to that. I'm sure you realize that the price is pretty stable right now, but as we all know, as production ceases, typically pricing does go up. This is a chart showing how much R-22 can be produced or was able to be produced back in 2013, 62 million pounds. And as you can see over the years, it's dropped off. This year it's 4 million pounds. And again, next year will be 0. So as you can see, it dropped off pretty dramatically after 2014. So as the pipeline dries up, Prices will go up and availability will go down. The Kigali Amendment. This is to the Montreal Protocol. I'm sure most of you are familiar with this. One thing that you really need to understand about Kigali, it is not an HFC phase out. It is an HFC phase down. And it started in 2019 this year. And every year it'll go down a little bit more. So there's over 50 countries that have signed on so far. The United States is not one of them. But the businesses here should get ready for a low GWP future. And that's what Kigali is based on. The U.S. Climate Alliance, this is, so far there's 23 governors that have signed on to the U.S. Climate Alliance, and it is over 50% of the United States population and over $10 trillion in economy. And they have all agreed to reduce greenhouse gases emissions by at least 26 to 28% below the 2005 levels by 2025. So each state may have different rulings. They don't all follow the same ruling. So you really need to understand what the rulings are, what the regulations are in your state. This was a proposed regulation it started back in 2016, and I'm sure, again, some of you are familiar with the 404A and the 507 not being used as a retrofit refrigerant in racks and supermarket applications, and that did get turned down, but California has adopted this. So it's called the California Air Resource Board, or CARB for short, and they have adopted all of these regulations. This is another proposed regulation from CARB starting in 2021. Commercial refrigeration containing more than 50 pounds will have to have a GWP limit of 150. Commercial refrigeration containing 20 to 50 pounds will have to have a 1500 GWP limit in 2021. New chillers in 2024 will have a 150 GWP limit. And air conditioning systems containing more than 2 pounds in 2023 will have a 750 GWP limit. This is just a proposed regulations. It hasn't been enacted yet, so stay tuned for that. On the retrofit side, or the service side, next year in 2020, the GWP limit will be 2,500, and in 2024, the GWP limit will be 1,500. So that's these are two proposed regulations from CARB. And again, some of the states will follow this, some will not, some will have their own regulations. So whatever state you're working in, make sure that you understand their regulations. So now let's talk about some conversion guidelines. This will help you understand how to convert a system over. This is just a basic conversion guidelines. We're not going to dig deep into troubleshooting or anything like that. That's what the tech support line is all about. So this is one of the PDF forms that you'll be getting from email, and this is a very good cheat sheet. It tells you what refrigerants to convert to from R-22, 134A, 404A, 507, and on the back side it'll give you relative capacities, applications, that type of information, more engineering type information. So this is a very good sheet to carry with you at all times. That way you'll understand what refrigerants will replace R-22, 134, 404, and 507. MO99 and U-22B, I'm sure you're familiar with those two products. They're the number one and the number two direct replacements for R-22 here in the United States. So most of these guidelines and considerations will apply to using any 400 series replacement refrigerant. Conversion processes may vary with each refrigerant, depending on if it's a blend of pure HFC or if it has a hydrocarbon in it. And for more detail, you can always go to Chemours.com /Ission Refrigerants MO99. That'll give you a more detailed conversion guideline than we'll talk about today. So first, you need to qualify the system, of course. The system needs to be designed for R-22 or 407C. It needs to be leak-free and in sound operating condition. There's no refrigerant that will fix a sick system. There's no refrigerant that will fix leaks in the system, so those need to be addressed first. System evaporator must be designed for an expansion valve, capillary tube, or a fixed orifice. 400 series refrigerants don't work well in flooded design evaporators. Not to say there's not flooded applications out there running on a 400 series refrigerant, but at minimum, you'll have to do a polyester oil change. Depending on how the system was designed, you may have to change components. So if you're thinking about converting over to a flooded design evaporator, make sure you call us first. We can help you out on determining what needs to be done to that system, or if that system is even a good candidate for a 400 series refrigerant. A lot of them will have to stay on R-22. Electronic expansion valves. Early on, electronic expansion valves were specific to one refrigerant. So if that system was designed for R-22 and the valve and someone had put a different refrigerant in that system, now the valve doesn't know how to react. So most of the times it just shuts everything down, and a lot of times people think it's the refrigerant doing it, and it is, because that valve was specific to R-22. Luckily enough, the new valves have control panels that you can select what refrigerant is in the system, and it'll work properly with a alternative refrigerant. But make sure that that control has the refrigerant in it that you're going to put in the system. For the commercial guys, these are two compressors that you want to stay away from a replacement refrigerant unless you want to do an oil change. These are the Danfoss SM and the Train 3D Scrolls. They have very unique oil systems, and they have to have mineral oil in there with R-22 to lubricate that top bearing. If you put an HFC refrigerant in there, even if it has a hydrocarbon in it, you'll have to do an oil change to polyester oil. That is the only way that you can properly lubricate that top bearing, is with POE oil. And for the guys that have worked with these types of systems before, it's not an easy task to do an oil change in these compressors. They're heavy compressors, larger tonnage, and most of them do not have an oil drain. So you'll have to physically take the compressor out of the system, turn it upside down, and change the oil. If the unit has more than one compressor in it, each compressor will have to have an oil change. You just can't change one. So now we can talk about components. Converting systems originally designed for CFC and HCFC to an HFC refrigerant may cause retraction in the O-rings. A lot of people think that it eats the O-rings. It does not eat the O-ring. The O-ring has had a swell rate depending on what refrigerant was in the system. For example, R-22 is in the system. That O-ring will swell to the R-22 rate. You go back with a HFC refrigerant, a non-chlorinated refrigerant, and that O-ring can't go back to its original state. So it will need replaced with another O-ring. There's not a special O-ring for HFC refrigerants. Just as long as you replace it with the original O-ring, you'll be fine. And failure to do this, you will lose refrigerant. It'll leak around that O-ring. Pre-conversion data, this is something that if you have the luxury to get pre-conversion data before you do a conversion, it's always best to get it. Many times guys get pre-conversion data and they figured out that that system just isn't working as designed. So there's a red flag right there that it's not a good candidate for conversion. I know a lot of times you get out there on the job and you've never seen the system before, and now your customer's wanting you to convert it. You do the conversion, nothing's working like it should. Well, it's not the refrigerant, it was the system. So again, if you have the luxury to get pre-conversion data, this is the time to do it. Recovering the refrigerant, you need to recover 100% of the refrigerant in the system. This keeps you from mixing refrigerants, and it is against EPA regulations not to recover 100% of that refrigerant. Oil analysis. Any commercial application, I would strongly suggest to get an oil analysis, especially in larger tonnage systems. That's going to tell you a lot what's going on inside that system, what's going on inside that compressor. Do you have high moisture levels? Do you have high acid levels? Do you have metal shavings floating around in the system? Remember, after the conversion and the system isn't working properly, again, it's not the refrigerant, it's what's going on with that system. So if you have components that aren't working properly, if you have contaminants in that system, it's just going to elevate problems after you do a conversion. Now, I understand on a hermetically sealed compressor on a residential unit, there's no reason to do an oil analysis unless you just wanted to take an acid test. That's fine. That'll tell you, give you some idea what's going on with the system. But I understand it's tough to get oil analysis with a hermetically sealed compressor. Install new filter dryers and oil filters if it is on a system. I get a lot of calls. Guys want to know, do I need to change the filter dryer? Absolutely. There's no reason not to put a new filter dryer on, especially if you have no refrigerant in the system. Filter dryers are on there for insurance. They will trap moisture. They will trap contaminants. That's the best thing you can do for a system, is to put a new filter dryer on it. On the commercial side, systems that have oil filters, make sure you change those. They may be full of contaminants. They may be full of metal shavings. So this is the time to do this. It's much easier to do it without refrigerant in the system than to charge the system and it's not working properly, and then you have to go back and change filters. Leak testing. Pressurize the system only with dry nitrogen. Never use compressed air or oxygen to pressurize a refrigeration system. And never exceed that data plate pressure. Depending on what refrigerant was in the system originally, the pressures may change. So make sure you don't exceed that data plate pressure, because you'll have leaks down the road. If you're using new 22B or MO99, you can use any standard leak detector that detects HFC refrigerants. Evacuation. Again, I get a lot of calls. Do I really need to evacuate the systems? Absolutely, because you need to get all of that moisture out of there that you can. And this is the best way to see if the system still has leaks. If you can pull it down to 500 microns and hold it at 500 microns, you know the system is leak free. Charging the system. You need to always invert that cylinder. There's no refrigerant manufacturers that I know of today that are putting pickup tubes in those cylinders. So you need to turn the cylinder upside down to get liquid out. Any 400 series blend has to leave the cylinder in the liquid phase, or it will fractionate. When initially charging the system, add to the high side or the receiver with the compressor off. Refrigerant charges may vary, so you need to start out with 10 to 15% less than that original R-22 charge. You will be undercharged, but remember, it's always easier to add refrigerant than to take it back out. Get the system up and running. Let it stabilize. With a residential unit, you need to let it run for a minimum of 20 minutes. On a refrigeration system, I would let it run for a minimum of 45 to an hour, depending on how big the system is, how much piping is in the system. You really need to let this refrigerant get stable before you start testing for subcooling or superheat. And always use the pressure temperature chart that's specific to the refrigerant that you're using. So if you're using new 22B, use new 22B's chart. If you're using MO99, use MO99's chart. You cannot use R-22's pressure temperature chart. Pressures are close, but they're far enough away that your superheat and your subcooling will be off. When you start adding the refrigerant, do it in 5% increments. Again, this way you won't initially overcharge the system. And here's the pressure temperature chart that you can use an app. It's called PT Calc. It's good for Android and iPhone. Label the system. Remember, you may not be the next person that's working on that system. So the next technician that gets there, he needs to know what refrigerant's in that system. So, put a label inside, put a label outside. Make sure that the labels are visible to the technician when he gets on the job site. And it's always good to do a post-conversion leak check. Again, we need to keep these systems tight. We don't want this refrigerant to leak out to the atmosphere. It needs to stay inside that copper tubing. And now get your post-conversion data. And again, if you had the luxury to get your pre-conversion data, you can compare the two, and they ought to be pretty darn close if the system was working properly prior to the conversion. This is a good, after you get your post-conversion data and you're having problems with the system or have any questions, and you give us a call, you can tell us what the superheat is. You can tell us what the pressures were, what the ambient is, that type of information that really helps us out when we try to troubleshoot that system. Refrigerant quality. This is becoming a big issue here in the United States. We're getting a lot of refrigerants from overseas. We did a sample of 5 cylinders at different locations, different manufacturers of 410A, and 4 out of the 5 cylinders failed. 2 of them failed composition, 2 of them failed air and non-condensables, and 1 of them failed moisture. And all of these refrigerants that are commercially available out in the field at the supply houses need to be AHRI 700, need to meet AHRI 700 purity standards. If you have bad composition, you can't use a pressure temperature chart to calculate superheat and subcooling, because if that composition's off, that pressure temperature chart isn't valid anymore. High moistures. Most of you have seen before high moisture in a system and you're freezing at your expansion valve or at your capillary tubes. That's the last thing you want with virgin refrigerant to put in a brand new system or a system that you just converted that has high moisture, and now right off the bat you got problems. Non-condensables. This shows up, when it's hot out, when you really need that air conditioner or refrigeration system to perform at maximum. So non-condensables is a big problem. Additives in refrigerants. Some manufacturers are putting oil additives in refrigerants. Have no idea why. There's no reason to have oils in refrigerants. Oil is in the compressor. No compressor manufacturer wants anything in those systems but refrigerant and oil, and needs to be the oil that the system or the compressor was designed for. So this is another piece of literature that you're going to get, and it'll actually show you the 5 samples and the components, the percents that they were off, the moisture levels, and the non-condensable levels. Here's a little section that we made up. This is kind of a fun fact here. Is it a myth or a fact? Is it okay to top off an R-22 system with a drop-in refrigerant? That's a myth. When you top off a system with an alternative refrigerant, or a 22 system already has 22 in the system, and you top it off with an alternative refrigerant, again, you have no pressure temperature chart you can use to calculate superheat or subcooling. So you're just flying by the seat of your pants, guys. Don't call us and ask us to try to troubleshoot that system, because we have no idea what the refrigerant is. You've made a new refrigerant. You have no idea of what the properties are, if you're getting liquid back to the compressor, if you're overheating the compressor. So it is not a good idea to mix any two refrigerants. Mineral oil can be used with pure HFCs like 407C, 427A, 421A. Again, this is a myth. Pure HFC refrigerants have to have polyester oil in the system. Again, I get a lot of calls. Guys have done this and they say it works. Well, it probably worked when they left the job, but the customer probably called somebody else out to fix that problem, because they knew that whoever did this wasn't a qualified technician. It'd be like putting mineral oil in a 410A system. That's why polyester oil was developed for our industry, is for 410A and all the rest of the HFC refrigerants. So if you're using a pure HFC refrigerant like 407, 427, or 421, make sure that that compressor has polyester oil in it. New 22B and MO99 have one or more hydrocarbons in the blend, so they are flammable. Again, that's a myth. Combining the right proportion of a hydrocarbon or hydrocarbons with an HFC refrigerant will improve mineral oil return, and do so without being flammable. MO99 and New 22B are both ASHRAE safety classified as A1. A is low toxicity, and 1 is no flame propagation. This is the same safety classification as 410A, 22, 404, all of the common refrigerants that you're using today. The proper way to charge a residential split system with a fixed metering device is by adding 30 degrees to the ambient to achieve design high side pressure. Again, another myth. Compressor superheat or subcooling is industry accepted and most accurate way to properly charge a residential split air conditioner. 30 over ambient, that goes back probably 30, 40, maybe 50 years ago, when we had 6 SEER, 5 SEER units. And yeah, you could charge it 30 over ambient and get away with it. Did it work as well as it could have? Probably not. But today, with the higher SEER, could be as low as 10 degrees TD across that condenser coil. Evaporator superheat should be set at 10 degrees on all applications. In most refrigeration systems, the evaporator superheat is determined by temperature application. Kind of a rule of thumb, low temp is 4 to 6 degrees of superheat, medium temp is 6 to 8, and high temp 8 to 12. Remember, this is at the evaporator, not the compressor. Get a lot of calls. Guys are checking superheats at the compressor with refrigeration systems. That's not the ideal place to check superheat. You need to do it at the evaporator. You can check superheat at the compressor, but that's not going to give you the evaporator performance. O-rings need to be changed because HFC refrigerants destroy them. We talked about that earlier. HFC refrigerants don't destroy O-rings. You have a swell rate. That's why you need to change out the O-rings. Mass flow of the refrigerant is used to determine system BTU rating. Another myth. The refrigerant mass flow will be a determining factor in sizing refrigerant flow controls like expansion valves and proper pipe sizing. So that's why you need to know what the refrigerant mass flow is when you are trying to determine the proper size for an expansion valve, for example, or the proper size for piping. It's not to rate the BTU rating of the system. System with liquid line sight glasses should be full at all times. Another myth. Liquid line sight glasses monitor liquid level and indicates if high moisture levels are in the system. In refrigeration especially, sight glasses could be full. Somebody opens up the door to the walk-in. The evaporator's needing more liquid refrigerant now, so it starts to flash. That doesn't mean the system is undercharged. That just means that the evaporator load is higher than normal. If you're converting an R-22 system over to a replacement refrigerant, a 400 series refrigerant, that sight glass will have more of a tendency to flash off than it would with a pure refrigerant like R-22. So just because the sight glass is flashing or bubbling doesn't mean that the system is undercharged. HFOs can only be used in new equipment. Again, another myth. HFOs are being used worldwide in retrofit applications. Here in the United States, a lot of supermarket applications have went to HFO refrigerants with great success. We have a lot of case studies. If anybody's wanting case studies, we can get you those on HFO retrofits. All refrigerants on the market meet AHR 700 purity standards. Well, we talked about that earlier with the quality of refrigerants. And no, not all refrigerant manufacturers meet AHR purity standards. So make sure you're buying from a well-known supply house. If that refrigerant cylinder says Chemours, Freon, or Opteon on it, you know it is a good quality refrigerant. Residential air conditioning systems can be properly charged at any outdoor temperature. Charging below 55 degrees is not a good idea, guys. You will overcharge that system, especially if you're trying to charge by pressures. This time of year, we get a lot of calls from technicians saying they're using twice as much of a replacement refrigerant than the R-22 system held. Yeah, you will when it's below 55 degrees out, especially if you're trying to charge by pressures. Get enough refrigerant in the system. Come back when the temperature gets up, 65, 70 degrees. Make sure you got a good load on the indoor coil. And then charge it by either superheat or subcooling, depending on the metering device. Residential heat pumps need to be charged by pressure. Another myth. The only way to properly charge a heat pump is by weight. Weigh the charge in, come back when you can get it in the cooling mode, and then check either superheat or subcooling. Every percent over or undercharged with a fixed metering device, a residential system will use that percent more in energy. Now, this is a fact. This is on a fixed metering device, capillary tube or piston. For every percent over or undercharged, that system will use that percent in energy. Hydrocarbon refrigerants. Hydrocarbons, they have very good heat transfer. They're very good refrigerants, but as we all know, they're highly flammable. They can be used in a wide range of EPA SNAP accepted ACR applications. The two most common hydrocarbons are propane R-290 and isobutane R-600A. You can go to the EPA.gov, search the SNAP list, and that'll tell you what applications are legal for use with hydrocarbon refrigerants. Hydrocarbons have a very low environmental impact, a very low GWP, and they are all zero ozone depleters. Hydrocarbons are highly flammable though. R-290 and 600A are ASHRAE safety classified as an A3 refrigerant, the A meaning low toxicity and the 3 meaning highly flammable. Hydrocarbons are compatible with copper components, mineral oils, and other common system components. The only component that you cannot use with the hydrocarbon system is a non-hydrocarbon approved electronic or electric component like thermostats, door switches, fan motors. All of those have to be approved for use with a hydrocarbon refrigerant. And most of the time, it's always best to go back to the original manufacturer to get those types of components. And service procedures are the same as we've used all these years with CFCs, HCFCs, and HFC refrigerants. In new household refrigerators, effective last year, September 7th, you could use now 150 grams versus the 75 grams that you originally could only use in those applications. Vending machines, again, you can use 150 grams. Residential and light commercial equipment, these are P-tacks, window shakers, that type of stuff. And new retail food, again, you can use the 150 grams with 290 or 600A or 441A. And again, all of this information is on the EPA SNAP website. Here's a service kit that you can get. It has 2 hydrocarbon cans, has the access valve, the protective case, and support material. So now let's talk a little bit about the next generation of refrigerants. They're already here. HYDROFLUORO-OLEFINs, HFOs. The brand name is Opteon. In 2005, HFO 1234YF was commercialized and quickly became the replacement of choice for mobile air conditioning to replace 134A. Now, if you have a newer vehicle, more than likely that vehicle has 1234A in it. In 2011, refrigerants are being used worldwide and with great success in both OEM and retrofit applications. And today, equipment manufacturers globally are designing around Opteon refrigerants like XP40, XP44, XP10, and XP30. So let's start out with XP40. ASHRAE number is R449A. It is a blend of 32, 125, 1234YF, and 134A. Again, it is safety classification as A1, lower toxicity and no flame propagation. It is a low and medium temp R-22 retrofit, low and medium temp 404A or 507 retrofit. GWP of 1282, 0 ozone depleter, and it is accepted on the SNAP list, and it is approved by major equipment and component manufacturers. XP44, refrigerant number is 452A. The blend is 32, 125, and 1234YF. Again, it has an A1 safety classification, and it is a low and medium temp R-22 retrofit refrigerant and a 44507 R-22 retrofit. The GWP is 1945. Again, it is a 0 ozone depleter. It is SNAP accepted, critical temperature of 167, and XP44 has a lower discharge temperature than XP40. And this has been approved by remote condensing unit equipment and transport. Thermo King has adopted this refrigerant as choice to replace 404 in their units. XP10, refrigerant number is 513A. It is a blend of 1234YF and 134A. Again, an A1 safety classification. It is a R134A retrofit. Has a very low GWP of 573, 0 ozone depleter, SNAP accepted, and a very high critical temperature at 207. And again, it is approved by major equipment manufacturers. We have partnered up with the NHL. If anybody is doing ice rink maintenance or is involved with ice rinks that are looking to retrofit to a safer refrigerant, we have plenty of white papers, case histories. We can do webinars. So again, if you have any customers that are thinking about converting over a ice rink or a curling rink over to a safer refrigerant, shoot me an email, give me their contact information, and I'll have the right people get a hold of them. This is Opteon XL41. The ASHRAE number is 454B, 132, and 1234YF is in a blend. And it has a safety classification of A to L. Again, the A means low toxicity, and the 2L is lower flammability. It has a real low GWP of 466, and again, it is a zero ozone depleter. And in 2023, Carrier will start using this refrigerant to replace 410A in their residential line. This is the letter from Carrier. You can look it up online, or again, if you'd like more information, shoot me an email, and I'll make sure that you get the right information. This is the Training and Technical Center in Indianapolis. We will be online here probably in the next month. This is some of the courses that we will be offering. Some are fee-based, some are free. We will do webinars. We will do on-site training. We will do training at the facility. So you will be receiving a lot of information here in the very future about the training center, about the courses, how to sign up for the courses, and what the courses are all about. This is the tech-to-tech number. Make sure you jot this down. A lot of you probably already have it on the pressure temperature chart from I-Core. That number has not changed. It's still manned Monday through Friday, 7:30 to 4:30, after hours on weekends. It will be answered by answering service and directed to the proper person to answer your question. So, we all understand stuff doesn't break down, from 7:30 to 4:30, Monday through Friday. All right, that is the end of the webinar. Let me get the questions up here. I don't see any questions. I'll wait here a few minutes. Somebody might be typing as we're talking. This is the last of 4 webinars that we did. We will probably be doing more webinars in the summer, in the fall, so stay tuned for those. All right, here comes a question in. Will this webinar be made available for later viewing? You will receive a PDF of this webinar here by the end of this week or the first of next, with other literature and links to download any type of material that you're looking for. Someone's asked what refrigerant has Carrier decided to use. The refrigerant number is 454B, as in boy. It's Opteon XL41, and Carrier will have their own brand. It's called Puron Advanced. All right, I think that's all the questions. Again, I want to thank everyone for attending today, and stay tuned because I'm sure we'll be having a lot more webinars here in the near future. Everybody have a good week and a good weekend.